Hi guys, you're welcome back to my channel. To those students out there who are writing Waec examination, how is the examination going? This video I want to drop now. I have dropped a video 2 years ago on nickel salt analysis. So the same goes for the Waec chemistry alternative B for this current examination which is going on. So I want you guys to watch the video. If you are the students who are writing the chemistry alternative B, that video is for you. Thanks.
You're welcome to my channel. It's been a while on my chemistry channel because I was busy with some other research. So today I'll be taking you guys on your chemistry practical for NECO 2021, the guide, a extensive guide on the NECO practical. And the practical we'll be talking about is mainly on salt analysis. And the salt we want to analyze is ammonia carbonate. And when talking about this ammonia carbonate, they are unstable when heat, and you can easily perceive the odor because they easily give off an ammonia gas. And now look at what you have on the bench here. We have I'll be using this baking powder to substitute ammonium carbonate. And again we have dilute HCl, we have barium chloride and sodium hydroxide with conc HCl. And when talking about this salt analysis of ammonia, there are other things you ought to know when talking about this, because when talking about this ammonium chloride, we ought to know the test, the observation, and the inference. And with that, I have my litmus paper here. And when talking about the base, we have to use red litmus paper because it turns red litmus to blue. So now, let's begin with the practical now. Here is my test tube. And for you to carry the first practical out, you have to bring out your red litmus paper. Then where you must it, that is, you have to wet the litmus paper. Then after that, you can use this our spatula now. Just pick half spatula of this, pour it into the test tube. So we have this, as you can see. We pour it in the water, into the test tube. So the next thing to do is that we have our wash bottle here. We pour the distilled water into the test tube. So you can see it now. So the next thing to do is that we have to moist our red litmus paper. And again, because we are substituting the baking powder for ammonium chloride, it won't change fast. It takes like a few minutes before it turns, but it's going to give us the result we needed even in the place of ammonium carbonate. So let's must this. You can see it. So you place it into the beaker. If we are using ammonium carbonate, we don't have to put in the litmus paper into the test tube. So now we have it in this form, as you can see. So now let's look at this particular litmus paper for some minutes. It's going to turn the red litmus paper blue. So let's observe it. As you can see, it's changing gradually. You can see. So it means that this ammonium carbonate or the baking powder we are using replace the ammonium carbonate. And don't forget, if we can't find the ammonium carbonate, we can use sodium, and we can use baking powder, or we use baking soda. So as you can see, it's changing gradually. So to tell us about this particular, so under your test, it said sample C plus distilled water. Again, sample C plus distilled water. So the observation would be sample C turns red litmus blue. And what will be written to the inference? So you can say sample C liberates an alkaline gas, because an alkaline gas changes a red litmus paper to blue. So the next one to do is that we have to, let's continue with this. Sample C in water. So when you pour this is our sample C now. So I'm going to pick up another test tube. And we can decide to continue like this now. So now let's pour our dilute HCl into this particular sample C now. Just a few drops of it. As you can see, what are you observing? It is called an effervescence. It evolves because anytime you get a mineral, when you open it, a particular gas will come out. It is called what? Effervescence. And with this particular effervescence, with what you can see with your eye now, that it's turned what? Lime water what? Milky. That's the observation. The first observation is that when you pour the dilute HCl into this sample C now, as you cannot see, it what? It evolves. So effervescent. So it turns lime water what? Milky. And when you swap to feel the what? The odor. When you swap to feel the what? The odor. It is what? Odorless. So now, that is the observation. And what is the inference? The inference is that from carbon dioxide, which is our CO2, and don't forget that our carbon dioxide, so it is what? Colorless, odorless. Are you with me now? And it's not, and so from carbon dioxide, the inference will now be from carbon dioxide to what? Carbonates. That is from CO2 to CO3 confirmed. So the next thing to do is that we have to pour this out. So I will decide to pick up another test tube. And now, the next thing to test it now, we are going to use our sample C, which is our baking powder, with sodium hydroxide. Our sample C with sodium hydroxide. Then, after the sodium hydroxide, because we are not provided with a boiling tube here, a warm water, so I'm going to decide to improvise by using this candle in place of the Bunsen burner. So now, when you pour your sample C into this test tube, before we carry out the experiment, a little drops of sodium hydroxide, a dilute sodium hydroxide plus heat. So we are going to look at what? The observation. So let's take a look at it now. These are our sample C. We pour it in the beaker with a little distilled water. So when you have this, are you with me now? These are sample C with distilled water plus few drops of sodium hydroxide. So, as you can see, so what I'm perceiving here is a choking or irritating smell. A choking or irritating smell. That is the observation. It is choking and what? Irritating smell. And again now, as I told you guys earlier, that when we are using this baking powder in place of ammonium carbonate, it takes time before the red litmus paper turns blue. As you can see, it has turned to what? Blue. Yes or no? Are you with me now? So now, with what we have here now, with what I perceive, can you get me now? I perceive what? It's choking or irritating smell. So now, if I decided to pick up a litmus paper, or if I want to test my sample C with dilute sodium hydroxide, what I will what? Observe there is what? A choking smell. So on testing this particular gas on litmus paper, we all know that it's going to what? Turn red litmus paper to what? Blue. Abi? Yes. So that is what? A good example of an alkali. Just pour it a little on the litmus paper, as you can see. So after some minutes, it's going to change from the red to what? The blue. So to tell you that what? Baking powder can also substitute ammonium carbonate. So now class, what are you guys to take? You say water, your sample C, which is our ammonium carbonate, which is being substituted with baking powder. Are you with me now? So you pour your dilute sodium hydroxide there. What do we observe? We can see we observe what? A choking or irritating smell. So on testing it on litmus paper, it turns our red litmus paper to what? Blue. Are you getting it now? So what do you observe there? The observation there is that on testing it on litmus paper, are you with me now?
Yes, sir.
So what we are going to write as our inference, because in this kind of test, ammonium chloride is also what? Noted. Is also what? Observed or noted in this, or let's say ammonium chloride is suspected, but if you want to write your inference on it now, it is showing us what? Ammonium ion. What did I call it?
Ammonium ion.
What did I call it?
Ammonium ion.
So the next thing to do is that I will pour this out, then I will decide to use another test tube. And we can see continue like this. Our sample C, a little, just add spatula of sample C. Then your dilute sodium hydroxide. What did I call it?
Dilute sodium hydroxide.
So when you pour it, as you can see, nothing changes there. Abi? Are you with me now? So if we are to warm this, and again before we go to another one now, the other one when you warm it, it's still going to give you our ammonium ion. So now our sample C plus dilute HCl. Are you with me now? Plus these are our HCl. Sorry, this is the conc HCl, and here we have our what? Dilute sodium hydroxide. Here we have our dilute what? HCl. So when you pour your dilute HCl into this, so you can see it fumes. What did I call it?
It fumes.
You can see now. So when you shake, so you know before it is more or less a milky color. Now, what are you observing now? Give us a word. A white precipitate. What did I call it?
White precipitate.
So now let's eat it. Let's see what we are going to observe when we eat it. Are you getting it now? If it's going to change the color or not. So let's see. So how do you place it? You said under your test, your sample C plus dilute sodium hydroxide plus dilute HCl. So we want to observe it now. Let's see. So as you can see, the thing is, yeah, I can see some bubbles here. But don't forget, we are going to have a white precipitate under the observation. Are you with me now? Or we call it fumes. Because when I pour the HCl into the sample C with dilute sodium hydroxide, it has a fumes forms. Are you getting it now? So, or we call it a what? A white precipitate. A white what?
Precipitate.
So when we eat it now, so let me use my tissue to remove the white, the black, the same. Class, what do you observe? What do you observe? Eh? You can see that. What you see? Is this not white?
Yes.
So white precipitate, right? And when you have the white PPT now, so in case I ask you, please, because your examiner will never tell you that you should use this or this, but just note your sample C when it's been mixed with dilute sodium hydroxide, which is what you have here, our dilute HCl, which is what we have here now. And when you eat it, we are going to have a white precipitate. What did I call it?
White precipitate.
What did I call it?
White precipitate.
And when you have that white precipitate, it is called that this particular thing is being observed under it, and it is called sodium chloride. It's called what?
Sodium chloride.
So when you have a white precipitate, not sodium chloride, ammonium chloride is being what? Observed. It's been what?
Observed.
It's been what?
Observed.
So under the inference, what are you going to write? That is, it means you are going to write that for every sample C, which is our ammonium carbonate plus dilute sodium hydroxide and dilute HCl plus eating, or either you place it on water bait or our boiling water too, is going to form what we call a white precipitate. A white what?
Precipitate.
Which is what we can see here. And when you form that particular white precipitate, we also observe ammonium chloride under it. So now, under our inference, it's going to be written as that we observe ammonium ion. Observe what?
Ammonium ion.
And so our inference is what? Ammonium ion. Our inference is what?
Ammonium ion.
Our inference is what?
Ammonium ion.
So the next thing to do is that I'll decide to pour this out now. Then I'll pick up another test tube. That is neat. So what we are going to do here is that we are going to put our sample C into the test tube as usual. And when you have your sample C into this test tube, so the next thing to do is that we have to pour 5 centimeters of water into our sample C. How many centimeters of water?
5 centimeters.
So we have this. So when you have your sample C now, so class, we are done using what? Sodium hydroxide now. So let's move to our barium chloride. What did I call it?
Barium chloride.
So now, which is what you have here, as you can see. So you open it, you pour a little of your barium chloride into the sample C with water. Do you observe anything here? Do you observe anything?
Yes.
So what do you observe?
Some bubbles.
God bless you. Some what? Bubbles. Abi? At the top of the thing. So he's telling you that when you pour your sample C using barium chloride, it is insoluble. It is what?
Insoluble.
Which is what you have at the top. It is what? Insoluble. And when particular thing that you observe is insoluble, are you with me now? So when it is insoluble, what observed there, or what is our inference? That is SO4 2 minus, SO3 2 minus, and CO3 2 minus is being suspected. Is what? Suspected. Is what? So now, with what you have here now, again, your sample C plus water plus barium chloride. Are you getting it now? We have some bubbles, Abi. It's telling us what? That particular thing is insoluble. Are you with me now?
Yes,
and when it is insoluble, our inference is that SO4 2 minus, SO3 2 minus, and CO3 is being suspected. It's being what?
Suspected.
It's being what?
Suspected.
And again, note one thing. If it is insoluble, it shows that your SO4 is being confirmed. It's being what?
Confirmed.
It's been what?
Confirmed.
So now, looking at what you have here now, I think we are going to run up in a few minutes. Looking at what you have here, if we should eat it. So let's see where we eat it now, or on either a boiling tube. Let's see what we are going to have.
Wait.
So, do you observe anything here? Do you observe anything? Do you observe anything? Class, do you observe anything there? Yes, is what? You can see what you observe here is what? A white precipitate. A what?
White precipitate.
Observation is what? A white precipitate, right?
Yes.
A white what?
Precipitate.
So now, the next thing is listen attentively. So what you are going to do next is that your sample C plus 5 centimeters of water, which is this, our little drops of barium chloride, plus conch HCl. Conch what? Conch what? So let's try it. We have this. Just a few drops. What do you observe? Effervescent. What do you observe? What do you observe there? And it turns lime water milky. It turns what? It turns what? It turns what? So now, what do we observe here? Our inference is that anything that turns lime water milky from, so it shows a what? A carbonate. A what? A what? A what? Again, before we round up the class, I would love to go back to the way we started the work, the practical. So, looking at what you have on board, I said you have to own a moist litmus paper. And when you pour that on your, moist litmus paper, which is your red litmus, your red. Then you pour your sample C plus water. Listen attentively. So, As soon as you just what? Place the litmus paper into the test tube, it turns what? From red to what? Blue. From red to what?
Blue.
So now, and our observation is that what? Sample C liberates an alkaline gas. So the next one is our sample C plus dilute HCl, as I've shown you guys earlier, is going to what? Evolve, effervescent. And anywhere we have the effervescent, so it is colorless, odorless, and it turns lime water milky. And what do we observe there? What we observe is what? Carbonate. Our inference should be what? Carbonate. So the next thing is our sample C, which is being substituted, or our baking powder, as I told you earlier, that it's being substituted or it's being replaced with what? Ammonium carbonate. So when you pour this into the test tube, then with our dilute sodium hydroxide plus it, are you with me now? So when you pour it, what are you going to observe there? We give us what? A clear PPT, that is a white precipitate. We have what? A white PPT, are you getting it now? And it is colorless, odorless. So our inference written there is from what? From ammonia to ammonium ion. And if we decide to continue like that, then we pour our dilute HCl into that particular thing. We are going to have a what? A fumes of formed from ammonium chloride. And with that, ammonium is what? Present. Resulting as the inference. So the last one is our sample C plus 5 centimeters of water plus barium chloride. We have a white precipitate. It have a white precipitate. Before I move to that, when you pour your sample C plus sodium hydroxide, we have a choking or irritating smell. So take note of that. So I've shown you guys a guide to the qualitative analysis of the 2021 NECO practical. Don't forget to subscribe, watch, share among your friends. Thanks.